Subscribe to Professor Academy. Press the bell icon.
Hi, my name is Aftab Khan and you are watching on Professor Academy. Today I'm going to discuss about the addition of vectors by graphical method. As in previous lecture, I have told something special about vectors, especially their components and about their two-dimensional, three-dimensional shape in structure. And in this video, how to add vectors graphically in vector algebra. Let's go. First, we should know about resultant vector. That what is a resultant vector and what is meant by resultant vector. I will define here shortly that a vector which produce the same effect is that produced by two or more than two vectors. Or in other words, you can say that a vector which produce the same combined or joint effect which is being produced by two or more than two vectors. For example, I will give a mathematical example here. We have two vectors. One is vector A and the other is vector. One is vector A1 and the other is vector A2. It will give us the combined effect if we add these vectors geometrically or graphically. It will give us a combined effect which is known as a resultant vector. That we have init vector, we have in vectors. For example, we have vectors A1, A2, and we want to add these vector. We will have plus A2 plus A3 plus A4 etc. up to init A in. Then all these vectors when combined it will give us sigma I from 1 up to n into A n. Here sigma I from 1 up to n, while A along with the n in a subscript vector A. Okay, here the sigma sign, here this is the sigma sign. Here the sigma sign is used because it represents us the summation of vectors in vector algebra. Therefore, we can write the combined effect of all these vectors is sigma or summation sign sigma I from 1 up to n A n. Okay, so this was the brief discussion about the resultant vector. Dear viewer, if you want to add vectors in a graphical method, we use head to tail rule. Basically, head to tail rules contains these three parts here: step number 1, step 2 and step 3. Head to tail rule contains these three initial and basics parts. According to these three steps or parts, we will describe how vectors are added according to head to tail rule. Let's go towards step number first. In step number first, we write here that first of all, the representative lines of all the vectors to be drawn with respect to suitable reference areas by choosing a proper scale. Here in this step number first, if you want to add vectors according to head to tail rules, you have to select the special reference areas. It means that in which direction I have to put the vectors which we are going to add. First, you should note that you should select the special or reference area. This is the first. And in the step number first, the second one is to choose your proper scale. According to that scale, you will express your vectors length especially. So I have two vectors in xy coordinates. We have two vectors. One is this is the y-axis and this is the x-axis, and this is the origin O. This is the x-axis and this is the y-axis. Let we have two vectors. One is vector A in this direction. Especially I have taken this with the reference area, where the reference area is this x-axis. Here it makes a certain angle or certain position with this x-axis. This is vector A, and the other is vector B, which is in this direction. Okay, this is vector B. So according to step number first, I qualified these two points, that first of all the representative lines of all the vectors to be drawn. This is the representative line for vector A, and this is the representative lines for vector B. As clearly mentioned here, that first of all you should draw the representative lines. So I draw the representative lines, and next, with respect to suitable reference areas, by choosing a proper scale. Actually, the proper scale depends on the person who are going to add the vectors according to head to tail rule. So it's up to that person, that how he select the proper scale. Okay, so step number first has been qualified here for the representative lines and choosing scale. This is the step number first. Next, in step number 2, I write here that redraw the representative lines of the vectors in such a way that the head of one vector coincide with tail of the other. Second step is very clear to be understand here. In this step, I have clearly mentioned that you should redraw the vectors in such a way that the tail of the first vector coincide with the head of the tail of the second vector must coincide with the head of first vectors. So I am going to express step number 2 here in vectors or pictorial diagram. Let I have according to the scale, I will redraw vector A and B. I will redraw, this is the x-axis and this is the y-axis. I will redraw the vector A and B in the same direction. This is vector A, which lies in the same direction, and no change occur while redrawing these vectors again according to step number 2. And I will pick off this vector B exactly in the same way as it is here in the first step. So the vector B is just like this. So I will draw here vector B like the first vector. So this is vector B. This was vector A, and redraw the vector B here in this step number 2. So this is the vector B. So according to step number 2, redraw the representative lines of the vector in such a way that the head of one vector coincide with tail of the other. Here I mentioned the head of one vector with the tail of the other, but actually it is depend on the location of vectors. So whether you want to redraw in this direction or whether you want to redraw and if you want to add a vector from this side, you must have the B in the same position while you redraw A in this position. Okay, so in this we exchanged both vector A and B. This is vector B and this is vector A. And later on we can put but actually the main matter is that you should place the tail of one vector to the head of another vector, and this is the verified step 2 in this diagram. Step number 3 is about the resultant of these vector is obtained by joining the tail of the first to the head of the last vector. Here the whole passage or the whole topic has been summed up in this step number 3. Here I described that you should add and you should draw the resultant vectors. You should obtain the resultant vector by joining the tail of first to the head of last vectors in graphical method. Especially this is the head to tail rules last point. Here it is mean that I must draw a resultant vectors which starts from tail of the first to the head of the last vector. So this is the resultant R. This is the resultant R, which is equal to, I will put a sign here, which is equal to vector A plus B. I come here from this side vector A and this side is vector B. Okay, this is the, and in other words, I can say that on this side, the resultant will be equal to R is equal to vector B plus vector A. So I get the same resultant for two different ways. Therefore, I can write here that R here mean resultant vector R is equal to A plus B. So this is the first, and again I can say that R is equal to B plus A. So this is the resultant vector which gives us the same combined effect as produced by vector A and vector B individually. Here I have told already that resultant vector is a vector which produces the same effect as produced by vector A and B individually. So I get that, and from this equation 1 and equation 2, 1 and 2, it has been clear that vector addition is commutative in vector algebra. For example, as this so equation 1 and 2 can be written as A plus B is equal to B plus A. So from this result I concluded here that vector addition is commutative, that is it obeys the commutative property in vector algebra.